Assalamualaikum and a very good day. You are from Group 16 with our project title of Cascade Ammonium Control in Activated Sludge Wastewater Treatment. Our team consists of 4 members, me myself, Muhammad Azrizan, Ooi Pei Shan, Azmeesa, as well as Kuhan, Tharu, Marajan. First off, I will be presenting on the introduction of our project. The primary goal of any wastewater treatment plant is to remove pollutant from water. However, the operation of wastewater treatment plant does have the impact on the environment. The activated sludge process, which is the one that we are studying on this project, is the most common biological wastewater treatment process used in a wastewater treatment plant, as it has been effective in removing not only suspended solids and BODs, but also nitrogen and phosphorus. In this project, control approach is proposed by using ammonia-based cascade control with different control schemes to optimize the control action and as well as to improve the overall performance of the plant. Next, I will be presenting on the problem statement as well as the objectives of this project. The problem statement of this project is that the wastewater treatment industry is becoming a significant industry in this world. However, the operation of wastewater treatment plant is contributing to environmental impact due to its energy consumption, use of chemical compounds, direct emission to the atmosphere, sludge disposal to land, as well as toxicity of chemicals. Until very recently, the lack of reliable instrumentation was considered one of the major obstacles for the implementation of control systems in wastewater treatment plants. Thus, the goal to achieve efficient and safe operation with high quality effluent while optimizing operating costs are still hard to achieve. Thus, we have come up with two objectives for this project, which is to investigate the effect of ammonium-based cascade controller with DO and DO plus NO control schemes on the wastewater treatment plant's performance, as well as to determine the most suitable control strategy that can increase nitrogen removal efficiency, reduce the carbon footprint produced by the treatment process, as well as reducing the plant's energy consumption. Therefore, I will pass the floor to Azmeesa to present on the process control system and justification. Thank you.
Hi, my name is Azmeesa and I will be explaining on the process control and its justification. To start, let's take a look on the overall wastewater treatment plant. This is a typical urban wastewater treatment plant that uses activated sludge as a treatment method. There are two main parts, which is the wastewater treatment plant and sludge treatment. Some of the units in the plant are clarifier, activated sludge reactor, anaerobic digester, and storage tank. In the treatment plant, the chosen controller is an ammonium-based cascade controller. The purpose of this control scheme is to reduce the energy consumed by the aeration process. The cascade controller is located in the fifth reactor with an external PI loop that calculates the dissolved oxygen set point for the DO default control system, which is the inner loop of the cascade control scheme. The cascade controller is compared to a default dissolved oxygen control and dissolved oxygen plus nitrates controller to see the efficiency of the overall plant. We can see that the energy consumed for the aeration process as well as the total energy consumption of the plant decreased for the cascade controller. Hence, the operational cost for the plant is also decreased. Since we use less energy, the carbon dioxide emission during the anaerobic digestion process is also decreased, thus resulting in lower greenhouse gas emission and less environmental impact. Lastly, the quality of the effluent of the plant is also better when using the cascade controller, as the total nitrogen concentration is significantly lower compared to the other two control schemes.
I am Pei Shan and I would like to talk about the challenging concern of this process control system. One of the challenges in this ammonia control strategy is the oxygen concentrations in the aerobic reactors are only adjusted when the ammonia in the final reactor is changed, which is usually too late in terms of influence disturbance dynamics and process time constants. Since oxygen has an influence on ammonia after a few hours, daily effluent ammonia peaks cannot be totally minimized. Excess ammonium discharged into water can result in major ecological issues such as faster eutrophication of lakes and rivers, reserve oxygen depletion, and poisoning in aquatic species. The second challenge is in full-scale plants. Assessing the energy saving potential using airflow measurements is challenging. Airflow consumption is critical because it accounts for nearly half of the plant's electrical usage. The controller performance is frequently impacted by limitations in maximum and minimum airflow capacity. At higher airflow rates, the efficiency of oxygen transfer is reduced. This is because of aggregation of bubbles, which reduce the overall transfer area towards the water phase and increase bubble rising times. When the airflow is too high or too low, the plastic carriers will clog at the controller. To improve the problems, there are some recommendations. For the first recommendation, feed-forward control that use influent ammonia concentration as a major disturbance should be introduced into the controller in order to enhance its performance. This figure shows the control scheme of feed-forward cascade PI control of the ammonia concentration. Because of hydraulic delays, influence ammonia changes a few hours before ammonia in the last aerobic reactor, allowing feed-forward control to improve ammonia reduction. Feed-forward control can react faster to a disturbance because it uses a feed-forward model to predict the impact of the disturbance before it affects the process. Second recommendation is to simulate using MATLAB. MATLAB was chosen as the appropriate application since it allows for the simple implementation of a variety of control algorithms. In MATLAB, the controller parameters were modified accordingly based on process understanding to achieve satisfactory controller behavior. To avoid clogging of the plastic carriers caused by too low or too high airflow, the maximum and minimum values of total airflow must be chosen carefully. Thus, as long as too low and too rapid controllers are avoided, the ammonium PI control system achieves near to the maximum possible energy savings.
Hello, my name is Kuhan and I'll be presenting the conclusion of this video. To conclude our video, the cascaded control system involves a master controller that controls the dissolved oxygen, which is used as a set point for the secondary controller to control the ammonium concentration by adjusting the airflow rate through a control valve element. There are several benefits such as lower energy usage for aeration, which saves costs, reducing water pollution and CO2 emissions, and improving effluent quality. Two different challenges for this system are such as late adjustment of oxygen concentrations for aerobic reactor due to unpredictable disturbances and varying or unstable airflow conditions, which affect oxygen transfer efficiency. Suggested recommendations are using a feed-forward feedback Cascade PI controller to predict and adjust for disturbances, and to use MATLAB to determine suitable control algorithms for maximizing efficiency of process and saving costs. In summary, we have successfully investigated the effect of different control schemes for ammonium-based cascade controller and determined the most suitable control strategy for improved plant performance.